In this example, we're given another demand function, 295 minus 0.2Q. And the first part is we're asked to write the revenue as a function of Q, and then we're going to maximize revenue. So, like before, we're going to have price times quantity. So the price is given by our demand function. Quantity is Q. So we're going to have 295 minus 295Q minus 0.2Q squared. That's our revenue function. And then we need to maximize revenue. So we're going to need to find the derivative of this and find the critical points. So the derivative, otherwise known as marginal revenue, is going to be 295 minus 0.4Q. And we set this equal to 0. And we're going to get a critical point when Q equals 295 divided by 0.4, which ends up being 737.5. Now, depending on what type of product you're making, the half might not make sense. If we're dealing with, for instance, liquids, it might be okay to make half of a liter of liquid, but half of a t-shirt, not so much. So we want to find the quantity that maximizes revenue. If this were the case, we should also think about, is this going to give us a maximum? So it's a critical point, but is this a max? There are two ways we can think about this. Our original revenue is a parabola. And the fact that the leading coefficient is negative, we know that it is opening downward. So what we found, this critical point, is at the vertex of the parabola when we have a horizontal tangent line, and it is a max. Another way is if we were to take the second derivative, we would get negative 0.4, which tells us we are always concave down, in particular right at our critical point. So again, we have a situation where concave down at our critical point, we have a max. So yes, it does create a max. And we want to know what is the revenue. And if we were to look at 737.5 and we plug in that, we get a pretty big number, $108,781.25. And it might make sense to plug in the whole numbers right around us. And it turns out for this one, we get the same answer. 108,781.2. So we're only a nickel difference between the making half of a t-shirt and whole t-shirts. And so the price, what price should we charge if we want to sell this? Again, we would plug in P of 737.5 into our price function, and we get 147.5. If we were looking at the difference of, we might want to, it might be easier to produce 737 to maximize than 738. So we'll put in the price 737, and we get, this is how much we should say of the demand or charge if we want to sell this many items. 147, thank you. 147.6, or both of those, and 147.5. So we have to be careful in the wording of this. If we knew what we were selling, does half of an item make sense, or do we have to stick with the whole items?